Hello all, welcome to your channel DIY Community. Please subscribe to this channel and get access to exclusive content and resources. You will also become part of our DIY community where you can connect with like-minded individuals and receive support. Hi there. In the previous videos, we have seen how to download all the tools necessary to create our distributed applications. In this session, we are going to create Synchronous TCP Server. So we are going to create a very minimalistic server just to understand how to use a Boost AI ASIO library to create a server. So we are also going to reuse some of the code which we have already created in our previous session. If you remember, in the previous session, we have created a client like this. So let's go over it very quickly. So this is a TCP client class which we have created in our previous session. This is a TCP client which is accepting IO context, shared pointer of it, IP address and port number. It is assigning all the member variables, the data necessary to create them, and then it is opening a socket. And there is an interface to connect, which is calling sockets connect API function with endpoint. And then it is sending a request to the server and processing the response after it receives. Basically, it is just printing it. So we have done a small change in this client program. So in the previous example, we were actually sending our request to a HTTP server on the web. But in this example, we will be sending our request to a server which is running on my own local machine here with 127.0.0.1 and the port is 8080. That's a change we have done. And another change what we have done in this code is we are using read until end of line is encountered. So this function get is sending our request to a server, and once it receives the response, it is going to read the response until it encounters a new line character. So there are many ways you can read a response from a socket. You can read a specific number of characters, or you can read until you encounter a particular character, and so on. So I will encourage you to please go and read the documentation of ASIO library, and there you will find like a lot of interesting ways you can design your server. So this is the change we have done on our TCP client. Let me compile it to keep it ready. Good. Now, before we proceed, I will also advise you to go over how client-server communication takes place, and also, if possible, just go over this OSI model here. You can Google it, OSI, and you can just go over the basic definitions just to understand what exactly it is. That's all. So this is a very high level client-server communication diagram. So as soon as you start a server, it binds itself to a socket and it will be listening and waiting for the client connection. Client starts, it creates a socket and it tries to connect. Handshake happens here and it accepts the connection. So once the socket, so at this point, a new socket gets created, which will be dedicated for this particular client, and all the client and server communication takes place through that socket. It will read from the client and it will write to the socket, and the same way the client will also write to the socket and it will read from the socket, and this communication channel gets established. Finally, when they are done, they close this socket on their end and they release all the resources. This is like a very high level diagram of a client-server communication. Now, this example is only for one client, but if you have a multi-threaded applications, then this server can support multiple clients at the same time with a dedicated sockets. So this is all it is in a nutshell. Now let's get back to our server application. So in our server application, most of the code is similar to what we have seen when we were creating our client, TCP client. So we are creating a context, and we are creating a socket object with using a context. Now I mentioned that don't make a copy of this context, always use a reference, preferably a shared pointer. So we are also creating an acceptor. Acceptor is using IP address of the server and a port number 8080. So it means that if some clients would like to connect to our server, they will have to use this port number 8080 here. So acceptor will wait here and listen to incoming request. And as soon as a request arrives, it will bind to a socket. So a socket will get assigned to a client for client-server communication. So once the client starts sending messages, server will read it. Now, so here we are again using a read until, and it will read one line at a time. So it will read until it encounters a new line character. After reading this thing, it's just an example here, so you can process it and send a response back. But in our case, we are simply sending a static message, hello from server, which our server will write to the socket where the client is listening, client is reading. And that's all, guys. So it will read, it will write, and then it will shut down. So this is a very basic client-server communication, and you can use the same thing to create your own application based on your requirements. So let's compile it and see if it works. Good, our application got compiled without any issues, and let's try it now. So we have a client on one side and we have a server on other side. Let's start the server first. So you can see that server has started and it's listening to a port 8080 and waiting for incoming connections from the client. The client will start here and it will initiate the handshake. It got connected, and based on the code, it is going to send hello from client, and server received the message hello from client, 18 characters, bytes. And then client processed it and sent the response back, which is hello from server, which is size 21, and our client has processed the message. As we have seen, the way we are processing is we are reading until it encounters a new line character. So it reads it and then it stops. That's it. Other side, if you press an enter key, it closes the connection and it releases all the resources. So this is in very basic how a client-server communication happens. So fundamentals are, you should create an IO context. Always remember to use reference. Don't use copy. And create a socket object using context. Create acceptor. Acceptor will listen and acceptor will accept on the socket. And it will once the clients it gets a connection, it will read from the socket and it will write to a socket. And once this read write is done, then shut down and close and release all the resources. So in the next stage, we will be transforming our code to a more object-oriented version. So the reason why I'm following this way is because in the first stage, I want you to understand the fundamentals. If you understand the fundamentals, you can design everything yourself based on your requirement. Now, in the second stage, I'm converting everything into object-oriented because that's what the goal of this tutorial is. We will be using all these fundamentals to design more practical applications of this thing. So that's where we are moving right now. So let me collapse everything so that we can go and understand step by step. Okay, fine. So similar to our TCP client, we have a TCP server class here. Now you see that I have deleted the constructor here. The reason why I deleted it is because I'm lazy and I didn't want it to add too much code here, just to keep us focused on what exactly we are trying to achieve here. But you can always write in many different ways here. So I'm using the other constructor by initializing with IO context. Now again, focus, I'm using a shared pointer here. Don't use a copy. It's not copyable. And then I'm providing the port number where you want to start your server. Then there is another function here where I have taken the code from my previous program and I have encapsulated everything under run. So run will run the server where it will try to accept a connection from the client. It will read until it encounters a new line character. It will process and it will send the message back to the client. That's all it does. And then there is also a destructor which will shut down and close and release the resources. Now again, I'm not writing too much code here. I'm not doing any exception handling. So don't hold me on that. So these are the objects in my TCP server. This is a IO context, which is a shared pointer. We have an acceptor and we have a socket. Now in my main program, similar to our previous programs, I'm creating a shared pointer of IO context and I'm creating an instance of our TCP server. Now TCP server is listening on the IP address of the machine where you're running it at port 8080. So when you say server.run, it is going to initiate the read and write with the client, and that's all, guys. So if you run it, you compile it, run it, it will do exactly the same thing. So this side is our server waiting for connection. This side is client, which is sending the connection. Handshake happens. The server receives the message from the client and send back the message back to the client. And client prints the message. The client stops and server is waiting. If you press key, it stops and it releases all the rest. So that's all, guys. So we have created client and server application which uses synchronous mechanisms to communicate with each other. So thank you for watching. Thanks for watching. Please subscribe to get more professional advice. In addition to our free online content, we also offer free online classes for students. These classes cover a range of topics and they're designed to help you enhance your skill and knowledge. We encourage you to join us and take full advantage of this opportunity to learn and grow.